Up, 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 up. Can you hear anything though? Nice. The YouTube live session for one individual only. Sweet. Good job. I guess I'm just gonna repost the link, see if anyone else makes it. Uh, this is weird talking to you, but you can only text me. Um, I don't know, it's just the audio didn't work. Unless you meant in life what went wrong. We have another person. Can they also hear me? Confirm it in the chat. Oh, back to one. I had a issue with the microphone on the first try, so I believe it's working now. But I had to post a new link. Unfortunately, the old one stopped working. So I'm gonna wait another 5 minutes and see if anyone else joins. Otherwise, three lucky people get to watch this forecast. Audio still working, and you can see me and my screen. This is the first live video I've done, so there may be additional technical difficulties. I will be doing them more throughout the season. Hopefully at least weekly. Uh, yeah, probably at least weekly with sometimes maybe some random ones depending on the storm situation. If there's a big storm, special storm, something exciting going on, um, I'm gonna give it until 8:50, 4 more minutes, since I had to stop the original live session and post a new link because the audio wasn't working. So thank you for joining, everybody, and just hang out for a few more minutes. Um, if you guys have any questions, put them in the chat for now. Happy to answer anything and everything. I'm in Utah, Salt Lake City, and I'm in my garage, and it just got really cold. Um, I put my kid to bed a little while ago and don't really have a place to do this that's far enough away from his room where I don't worry about waking him up. So for now, I'm in the garage and it's cold. It's like 45 degrees right now. Had some crazy hail. Portland, of which coast? Jefferson. Uh, no, I'm from Massachusetts. I lived in New England, mainly Massachusetts, for 30 years. And then I've been here in Utah for almost 10 years. Where do you ski if you live in Portland, Jefferson? Nice. How do you like Mount Hood? I only went to Mount Hood once, just chased one storm there a couple of years ago. Drove out to Oregon to do some split boarding at Willamette Pass, and then checked out Mount Hood. And I've been to Bachelor a couple times preseason to do some touring there too. But yeah, I don't get to Oregon that often. Sometimes though. All right, you five brave souls to be on my first YouTube live. Um, I'm gonna get started. Feel free to throw anything in the chat. Um, since this is the first one, I have a loose idea of what I'm going to go over and what I want to talk about. Um, initially, these are planned to um, discuss the forecast, snowstorms, snow forecasts, uh, pretty much anywhere in the world, but uh, more focused on North America. I want to give people information on how I do the forecasting I do that helps me chase storms. So perhaps some of the stuff might be too technical, more technical than people want. Um, if that is the case, then moving forward, I might do less of that. But for now, that's kind of the point. You can get snow totals, snow forecasts anywhere from a lot of different places. So I want to do more than that, um, and just give people a look at what's going on with the weather, how the storm is playing out, the specifics of why some places are getting what they're getting and why some places aren't. So that's what I'm going to do. I will start by looking at the satellite view of the North Pacific, Northeast Pacific. Over the western US, you can see some clouds moving from southwest to northeast. That's the current storm that we're dealing with right now across the Intermountain West and much of the western US. Um, you can see that there's pretty thick cloud cover over Utah, Colorado, Arizona, Idaho, and Montana too. So that's the storm that's happening right now. This is a live radar from just the last 12 hours. You can see the sun setting, so the shadows coming across into the Pacific Ocean to give you an idea of the time frame that we're dealing with. Um, so yeah, so that's the storm we're looking at now. Uh, Up in Oregon and Washington, the Pacific Northwest, you can see that there's not too much clouds right now. The snow that fell today was from this storm, but it's moving further inland and away from the Pacific Northwest. So there will be a little bit of a break in the action. But if you look off to the west in the Pacific Ocean, you can see this feature. And let me ask you guys, can you see the movement of my mouse at all? Maybe when it's not oversight. So yeah, maybe I'll keep it below. But you can see this long strip of clouds from over in the central North Pacific, um, and it's approaching the Pacific Northwest. It looks like it's already getting into British Columbia. But this is the next storm that I briefly talked about in the forecast video I posted on Instagram with an atmospheric river. And this long, thin strip of clouds is the atmospheric river itself. You can see this swirly bit of clouds up here. That's another low pressure system in the Gulf of Alaska. And you can see it spinning up there, which is cool. Um, the clouds going around it. Um, yeah, and it's a low pressure system, so the clouds are going around it in a counterclockwise direction, and it's also steering this atmospheric river into the Pacific Northwest. And I think it's really cool. You can see that on the satellite, this uh, thick clouds, but a thin band of clouds. Relatively speaking, it's narrow, um, and that will be arriving well tomorrow afternoon in the Northwest. I'll get to those details later, but it's always good to just take a look at the satellite picture of the region that the storm is happening in. So here we are just zoomed in a little bit more. You can see, nice that it zooms like that. Um, you can see the storm over the western U.S. right now. Again, you can see the clouds are moving southwest to northeast. We have the low pressure kind of centered right here, and then the clouds streaming around it in a counterclockwise direction over Nevada, Utah, Wyoming, Idaho, Montana, getting into Colorado too, and a little bit down into the southwest as well. And again, this crazy atmospheric river that is heading our way in the Pacific Northwest. But for now, we're focused on the Intermountain West with the storm that uh, brought some snow to British Columbia, Alberta, Washington, Oregon. Not any big totals. Probably just a few inches. I think I was calling for 3 to 8 inches from this initial storm at upper elevations. Um, and it looked like that's about what they got. The snow levels dropped down to 4,000 feet or snow. It was snowing at the base elevations of Crystal, Stevens, um, I think Timberline as well, with some accumulating snow, which is nice for October. It's pretty cold for this time of year, these temperatures. Um, but yeah, the bigger impacts from this storm are going to be further inland in Utah and Colorado and Montana. Um, so now we're going to look at the upper level pattern with this storm that we're dealing with right now. Um, this is the 500 millibar pattern, which is like 30,000 feet up in the atmosphere. We look at the pressure pattern in regions to figure out where storms are, um, and how they're going to move across the country. So this image right here is from a couple days. You can see this is the storm up here in the Gulf of Alaska that is currently down here over the U.S. So this is a couple days ago before it came inland. Um, as it came inland yesterday over the Pacific Northwest, that's what brought the snow to the Pacific Northwest. And then today it has moved inland. This is from about 6 a.m. in the morning, this morning. And then as the storm continued to move inland, you can see probably the interesting and crucial part about this storm is that as it came inland and as it comes inland, um, this is where we are right now, Thursday at 6 p.m. So, it's like I said, over the western US. If you go back and look at, so this is what we're looking at right now. This is kind of the center of the low pressure. 6 p.m. Thursday night. It's a little bit later now, but they go in 6 hour intervals. But if you look at the satellite, this is where that storm is, and then you can see the thicker on the southeast side of the storm. That's usually where the heaviest precipitation is uh, during a storm, given the location of the upper level low pressure system. It's where you get the most lift and condensation and clouds and precipitation. So that's where we are now, and that's bringing southwest winds, southwest flow across much of this region. Let me zoom in a little more. Yeah, over much of the Intermountain West, and that's what's bringing the rain and snow that we're seeing in uh, Montana, Idaho, Utah, Nevada, Wyoming right now. If you go back to the radar, similar thing to look at. The storm itself is centered right here, but all those clouds and the lift and the precipitation is southeast of that storm. So you can see it. It's raining and snowing in Idaho and Utah, a little bit in northwest Colorado, and southwest Montana as well. From tonight through tomorrow is when things get a little more interesting as the storm continues to move inland. You can see if you look closely, right here we have the base of the trough. It's these upward curved contour lines. that's the low pressure. You can see them going all the way up there. But as the storm moves inland, you see this little closed circle happening, and then you see that closed circle getting bigger, and that's really the crucial part of this storm. Sometimes these low pressure systems will close off, like I just described in the pressure map. That's exactly what's happening. It's become a closed circulation in the upper atmosphere, and that has a couple of important effects. One is that when these storms become closed off like this, they basically become separated from the normal winds that go west to east across the western US. The jet stream generally flows west to east, but when these storms close off like this, they become cut off from the predominant flow, and that allows them to slow down and stick around in one area for longer than a storm that doesn't close off like this. So that's one impact. It slows it down and causes it to potentially linger and bring a prolonged period of precipitation. Um, Secondly, what happens is, since this is a closed area of low pressure, with um, the door just opened behind me, with counterclockwise flow around this low, it's going to cause you to have different wind directions depending on which side of the low pressure system you're on. And so for that, I'm just going to zoom in a little bit closer so you can see it better. But yeah, so we're going to have southwest flow down here, but on the northern side, it's always going to be always think about the winds going counterclockwise around this low pressure. So on the northern side, we're going to have winds kind of out of the northeast and more on the north over here, and a little bit of northwest on the backside, and then we're getting more west and then back down to southwest. So that that creates some interesting circumstances where over a short distance, let's say in central Arizona, you'll have southwest winds, but in uh, eastern, southeastern Nevada, you'll have something like northeast winds or north winds. And that can make the forecast tricky. And, generally speaking, I'm going to close that door. Generally speaking, with the storms going from west to east across the country, predominantly we're getting winds out of the west, and with a big mountain range, the Rocky Mountains, which generally runs north to south. If you have winds out of the west, you get some large scale orographic effects, um, resulting from the winds running into the mountains and then rising. So generally, winds out of the west are what brings an additional uh, precipitation intensity with all the storms. So if we get a storm like this that's closed off, and getting some winds out of the east or the northeast or the north, those are typically, in general, not as beneficial for snowfall in the mountains, just based on the location of the storm. I mean, if you get winds out of the east and the northeast along the front range of the entire Rocky Mountains, that can benefit, kind of this area along the front range of the mountains. But for the most part, we want winds out of the west, with storms. And, most of the time, the storms are coming in from the west, crossing the western US. You start out with winds out of the west or southwest, and then after the storm moves through, you'll get a transition to more northwesterly winds, and that's generally the pattern that we get from these storms, that we want from these storms. for most areas to benefit in the best way for snow. But this storm is not doing that. Like I said, it's closing off in the southwest near the Arizona, Utah, Nevada border. Um, it's going to stick around. I mean, here's a good way to look at it. Each one of these uh, clicks through where you're seeing stuff moving is a 6 hour period. So starting right now, you go ahead 6 hours, you can see that storm system is moving southeast. Again, you can see it's moving southeast over another 6 hours. Again, it's moving southeast over the next 6 hours. And then it moves a little bit further during that 6 hour period, Friday afternoon to Friday night. But then for the next, let's see, one, two, three, four, five, six, the next six hour period. So for the next day and a half, the storm basically stays in the same spot and then doesn't start to move out of the southwest until Sunday. Um, and that's basically, that effect that I talked about, where if the low pressure in the upper levels becomes cut off from the predominant flow, it stalls, it kind of gets stuck and can linger for many days. And where it lingers is very important in terms of who gets snow, because like I said, the winds during these types of storms can be quite different over a small distance. um, with this storm stalling and lingering, basically over Arizona, you're going to get southwesterly winds into Colorado, southwestern Colorado, and then southerly winds, and then even some southeasterly winds, which is still pretty good for the San Juan Mountains in the southwest corner of the state. Um, but also, once that happens, the the dynamics of the storm are more focused on Arizona, New Mexico, and Colorado, and the rest of the West. Things are kind of winding down once it gets to this point over Arizona on Friday night. So most of what's going to fall in Montana, Idaho, Wyoming, Utah is going to happen tonight and tomorrow during the day before this storm, closes off and moves too far south to really do much in the central and northern Rockies. Um, okay. So the next map to look at is, again, it's looking at the pressure of the atmosphere, but it's also looking at the lift that is resulting from the storm. For any storm to produce precipitation, for any precipitation to fall anywhere really, you need some mechanism in the atmosphere that causes lift. When moist air is lifted, it condenses and turns into clouds because the colder air at higher levels in the atmosphere can hold less water than warm air. So as the air rises into colder air, um, the air can't hold the moisture anymore and clouds form and then precipitation forms. And you need some lifting mechanism in order to cause that to happen. And, like I said, that's the case with all storms, all precipitation. There's different types of lifting mechanisms, um, but it's essential to have any precipitation. You need a lifting mechanism. So when I look at this map of the pressure as the vorticity, which we'll just refer to as lift because that's what it is, the darker oranges and reds mean more lift. So right here was this morning. You can see that there's a good amount of lift over the Pacific Northwest, and that's kind of one of the reasons why the precipitation was there during the day today. And then as the storm moves a little bit farther inland, you can see, that lift that's resulting from this storm and the cold front as well. kind of moving farther inland. We're still getting southwest flow across much of the west, like you saw in the satellite map at the beginning. Um, and then, tonight, as this low pressure system moves a little bit farther southeast over Idaho, Nevada, and Utah, that lift that we need is being stronger, is getting stronger over that same area, Utah, Nevada, Wyoming, and Montana too. But it's not sticking around for long, and as that low is off, like we've been talking about, um, that lift really, the area where that lift is basically smaller, and it's just kind of centered around that low pressure. And we still have it generally to the east of the low. Southeast is kind of where the most lift is. um, but uh, you know after this phase of the storm quickly moves through, storm closes off in the south, we don't really have any more lifting mechanism in the rest of the west. So that's kind of why the snow is going to shut off after tomorrow morning or midday. And then you can see as the storm lingers there, the lift kind of stays in the same place for a while. Um, so next, I'm going to take a look at the um, temperatures at 10,000 feet, the winds at 10,000 feet, as well as what's called frontogenesis. And that basically just means when there's a cold front or a warm front, basically when two air masses meet, um, one will move into the other and cause the opposing air mass to rise above it. And that's basically another um, lifting mechanism. And since the cold air is more dense, the warm air basically rises above it. And that gives you an additional mechanism of lifting when a front is moving through the region. And you can see where these purple circles start to show up more. That's where the cold front is. And you can also see it by the blue line and the red line meeting. That's where the cold front is coming into the warmer air mass that was in place. And, you're getting some activity along that line where the cold front is. And um, so that was initially from, today and this morning. Uh, the cold front, it's interesting. It's not that strong of a cold front, and it kind of falls apart as it moves through the region. Normally you might expect to see this, frontal zone continue all the way through, into the Intermountain West, but it kind of falls apart a little bit. And then, there's another uh, front associated with the storm that moves through this evening. That's what's happening right now. Um, and it's not surprising that you see this strong frontal zone with these purple circles here, um, is coming through western Utah, where, as I was saying before, we just had a really strong thunderstorm. Um, that cold air mass came in and wedged itself under the warm air mass, causing that warm air mass to rise very rapidly, and that led to the strong thunderstorms with rain and hail and a lot of lightning. Um, but yeah, after it kind of reaches Utah, you don't really get too much of that, frontal impact anymore. And you're not really getting any enhanced lift because of the cold front at that point. Um, and from that point forward, we're relying more on the large scale lift that I talked about on um, the previous uh, map. This one we're talking about large scale lift, um, and also orographic lift. You know, when moist air runs into a mountain range, it has nowhere else to go but up. So that's another lifting mechanism that causes precipitation in the mountains. Um, and we'll be relying on that in Colorado for the next couple of days, as well as the large scale lift that I talked about before. Um, okay, let's take a look at the cold front, and then we'll look at the winds. So this is just a temperature map at around 10,000 feet. The freezing line is where the distinct color changes right along here. You can see 0 for 0 degrees Celsius right there. Um, and this was this afternoon. You can see that the leading edge of the cold front was already out over uh, Utah and Nevada and Wyoming, but the real cold air associated with this front is back here. Is already over Washington. I'll go back a couple model runs so you can see the cold front uh, coming into the northwest. You can see this is yesterday around noon. The cold air is really just getting into Washington and British Columbia, and then it's moving further inland. Um, but like I said, the cold front, it kind of falls apart. Oftentimes you would expect this sort of bulb of colder air to continue to progress southeast across the Intermountain West. And oftentimes, these colder -10, -11 Celsius temperatures would make their way down into Nevada, Utah, Colorado. But the cold front falls apart to some degree. We're already losing some of that really cold air. It's kind of up in Idaho and Montana. Um, and that's related to the low pressure system closing off. Um, and on Friday at noon, by the time that low is down here over Arizona, the coldest air that's still hanging around is -6, -7 at 10,000 feet, which is not that cold. And then at that point, we start to warm up really over much of the west. Starting um, on Friday. We have that cold air lingering down where that closed low pressure is. It's basically trapped like a pool of cold air around it. Um, and since it's cut off from the main flow over the region, warm air is coming in and everything's warming up, but that closed low pressure is still holding on to a little bit of cold air for a few days into Sunday and even into Sunday night and Monday before, we talked about that low pressure hanging out for, like 2 days or more before it starts to move out. So I don't love that in general for snow and storms and chasing storms. Like I said, if that low wasn't doing that closing off thing over the southwest, then you would typically expect this cold front to stay together and bring this cold air somewhat further southeast. It's not necessarily always going to get um, that far south and east. It's just dependent on the storm track. But um, usually, if that's the case, you're not really going to have precipitation, that far into the southwest and the Intermountain West. If you have a storm track that's further north, you'll have the cold air that reaches, this part of the country, and the precipitation will kind of be in there too, but there won't be much down here because the storm track will be to the north. But with these closed lows, they're unique, a bit weird. Don't really like them that much. Um, you'll get precipitation to come much further south than the cold air gets. Um, and so you don't really get the cold air into these regions, but you still are going to get, some decent precipitation as the storm moves into the west before it closes off. During this phase of the storm, which is right now, um, the cold front's coming in. We're just dealing with a more garden variety type storm. Um, generally southwest flow across much of this region. Um, but yeah, once that storm closes off, everything changes. And not only do we not get the cold air penetrating that far south, but it also messes up the winds completely. And that's what we're going to look at here. Um, this is windy.com. It's a interesting, cool weather website. I want to make some of these wind lines more noticeable so you can see them better, but this will probably do. So let me go back a few frames to where we are now. It is Thursday at 9 p.m. So this is what the winds are looking like now across the west, with the storm located here, as we've been talking about. You have the winds coming around counterclockwise and giving us that strong southwest flow across, most of the region. Starting to get some different wind directions up here as the storm tracks farther south, but definitely some strong winds, northerly winds on the backside of the trough, that upper level low, transitioning to southwest on the southern and eastern side. So that's good. That's typical. That's what you get at the start of most storms as they move into the west. Generally, since they move west to east, you get southwest flow ahead of the storm. As this storm continues to move inland and becomes closed off, like I keep harping on, let's zoom in on Utah, for example. And we're a little bit higher than 10,000 feet there because with the Colorado mountains rising over 14,000 feet, the winds at the 10,000 foot level aren't as representative of what's going on as wind at 15,000 feet. But here is Salt Lake, and this is where we are now. Generally, just have some, southwest winds like I talked about. Um, you know, if we want to have a really good storm, the winds become northwest like they are in this frame, but you can also see these winds are really weak. They're not strong enough to produce um, significant orographic effects after the passage of the cold front, um, the weak cold front. And then we quickly transition the winds to the north as the closed low, positions itself over Arizona. And then following that, we're staying north into Friday morning. And then we start getting more of a northeast wind Friday morning. Midday, we're purely northeast. And for northern Utah and most of the mountains, once the winds go north, that's not good for precipitation. It's much harder to get snow to fall with north and northeast winds. This mountain range in Utah, for example, the Wasatch runs north to south. And if you have winds coming out of the north, then these winds are just going over mountains. And they're not having this area of low elevation where they can travel a distance and then reach the mountains and get forced to rise and give good precipitation from orographic impacts. So once these winds are going north and northeast and east, it's really not great for Utah at that point. We're just relying more on that large scale lift to get some additional precipitation. So that will happen tonight through tomorrow morning. But as the winds go more east, the less likely the heavy snow will be falling. By Friday evening, if we zoom in a little bit farther south over Arizona, you can see this is kind of where the center of the low is. And it's a very, small scale example, but you can see the winds in a counterclockwise direction around this low pressure system. And if you start to zoom out, you see that's happening at a bigger scale. And, in this case, even just over, a number of miles, you're having different winds. But from a bigger scale perspective, starting even, right now, we're still seeing southwest flow over the region in Colorado as that low moves farther south and closes off. We're still seeing southwest flow, but it's becoming more south, especially over the San Juans in southwest Colorado. And then throughout the day on Friday, 9 a.m., noon, 3 p.m., mainly winds out of the south. In the afternoon, they start to get more of a southeasterly component, which is fine overall for the San Juans, but it's not as good for the ski areas for the most part. Wolf Creek and Silverton want more of a southwest wind given their position in the range. Purgatory is a little bit better positioned for southerly winds, so that part of the San Juans will probably do best. And then Telluride up here, southwest, southeast winds aren't good at all for them. They do better with northwest winds, given their position on the northwestern side of the San Juans compared to Silverton and Purgatory and Wolf Creek that are more along the southern part of the San Juans. But through Friday night, we're still having, let's look a little bit higher, back up to 15,000 feet, 600 millibars. We're still having almost due south winds in southwest Colorado, and that's tomorrow night at 9 p.m. And then at that height, not until tomorrow night around midnight do they really start to go southeast, which again is still fine for the San Juans on the whole. The parts of the San Juans that are facing south will just do better than the parts that are facing southwest, a little farther west, and also a little farther east. Where Wolf Creek is when the range kind of bends to the southeast. But overall, southerly winds are good for the San Juans, whether it's due south, southwest, southeast, will shift the jackpot zone a little bit. And, it'll shift it enough that places will do better than others given that shift. Like I said, southwest winds are good for Silverton and Wolf Creek. Due south is better for Purgatory and south of Silverton. So again, that's where I expect the jackpot to be because of those winds being due south and southeast, and those are as a result of the position of the closed low pressure and the winds circulating around that low pressure. If this was positioned, farther west, and stalling over, the Nevada, California, Arizona border, then we would have what, is going to happen basically tomorrow morning. If the storm is back here, let me zoom in a little bit. If the storm is back here, we're getting more southwest flow into southwestern Colorado, and that's going to benefit Telluride and Wolf Creek more. But it's not stalling there. As I showed you, it's going to progress farther south and farther east and stall closer to the Arizona-New Mexico border, which shifts the winds just enough to make it due south or, eventually southeast. And, that's really the difference with this storm, why, Wolf Creek and Silverton are probably not going to get the most snow. Purgatory's a little bit lower, so, the actual snow totals at the resorts might wind up being pretty similar, but at similar elevations around Silverton, around Wolf Creek, around Purgatory, um, you know, that Purgatory area and south of Silverton is probably going to do a little bit better, just because there's more time with due south and southeast winds. It's interesting over Arizona. Arizona Snowbowl, it's big stratovolcano north of Flagstaff. Um, they can really get good snow from any direction, because there aren't really many other mountains around. If you zoom in close, you see that stratovolcano right there. There's nothing in any of these directions to block the flow that will lead to good orographic precipitation. Since the resort is on the west side of this little kind of open volcano thing, westerly and northwesterly winds are usually best. So that's kind of what you're looking for. But, with this closed low pressure parked over Arizona, another thing that you get is that the winds are typically much weaker directly uh, below the area of closed low pressure. And you can see it here. Like the greens are lower winds, and then yellow to orange is higher, and then pink is higher, and then purples are even higher. You can see right around the closed low pressure, these winds are really weak. Like there's practically no wind at all there. And then on the backside of on the west side of the trough and on the east side, they're much stronger. And in order to get orographic precipitation, the winds have to be, at least strong enough. I mean, 5 to 10 knots is kind of the bare minimum where you're going to get anything. From an orographic perspective, you need a strong enough wind to push the moist air into the mountain barrier, and then to push them up the mountain barrier to get the rising that we're looking for. And if the winds are so weak, as they often are, over the center of the closed low, you're just not going to get that much orographic effects. So that decreases the ways that you can get, heavy precipitation. This is Saturday at 6 a.m. You can see by that point. So, the storm is over Arizona, but on Friday night at 9, it's weak northwest winds over Arizona Snowbowl and north of Flagstaff. But then, Saturday morning, the winds are due east. They're a little bit stronger, but still pretty weak. Not going to do much for orographic impacts. Like I said, we'll be relying on the large scale lift that we talked about back here, that's resulting from the upper level storm dynamics. And then also potentially some frontogenesis leading to some lift that might cause some precipitation. But as I mentioned before, the cold front is not too strong when it gets down into Arizona. So that impact will be less. There still will be snow in northern Arizona mountains, but I just don't think it's going to be anything significant given this type of setup. And similarly, if the storm, even as a closed low, was farther west and stalling farther west, maybe you get a prolonged period of southwest winds into northern Arizona. That can be really good. I've definitely seen some big storms with that. They tend to be uh, a little bit on the warm side on average if you're having southwest winds because it's bringing in air from the south, which is warmer, but you can still get a lot of snow. But where this low is positioned, you're getting very minimal orographic impacts. The winds are weak. The direction isn't ideal. And it's just not a great setup, but still get some snow. And I'll get into some totals later. Um, this whole time, you've probably been able to see that, over New Mexico and into Colorado, the winds are much stronger, plenty strong for good orographic effects, good lift. The winds are strong enough to impact the mountains. When they hit them, the air will rise, it'll force precipitation out, and that will cause there to be heavier snow there. And that's just the lay of the land with the position of this storm. Um, so we've looked at the upper level setup, the position of the trough as it moves into the west and then the southwest, how it starts with kind of just a normal trough of low pressure in the west with southwest flow, solid, very common setup in the winter with a cold front. Things start to go awry when the storm starts to cut off and head further south. The cold front kind of breaks up, doesn't really stay together and push through more of the region. We get unfavorable wind directions in many areas and weaker winds than we'd want in many areas. And like I said, given the specific location of this closed low pressure over Arizona stalling, it really brings the best orographics for this storm, this entire storm, into southwest Colorado. Um, so the best, orographics from this storm will be in southwest Colorado, and that's kind of the main reason why the most snow is going to be there. There's some decent large scale lift that went through Washington for some snow today, into Utah for snow. That's too far ahead. Washington today, and then in Idaho, Montana, Wyoming, Utah, some good large scale lift. Southwest flow is good for these mountains, so there's orographic impacts as well. But once that storm closes off, you lose both of those lifting mechanisms, and precipitation is going to stop for the most part. You're not going to get any heavy precipitation, so that's why the totals aren't going to be as significant there. I think that's probably a good enough explanation of the large scale and small scale atmospheric dynamics setup. We talked about upper level pattern. We talked about cold fronts and temperatures. Talked about winds in most locations and what's favorable and what's not. So we can move on to looking at some totals. Well, let me take a look at this real quick. I put it in my tabs here to look at it. So all of that stuff we just looked at, those are just basic things that you can look at on many different sites that have weather model data. the first couple of things is just satellite, and that's live or, past stuff. But this upper level pattern, the lift that's going on with this storm, the cold front, the wind direction, those are all just kind of basic weather parameters that you can look at many different websites. There's a lot of different models out there that give similar um, outlooks, but not exactly the same on weather and storms. I've kind of been mixing between the American model and the European model, just kind of um, by chance. Um, some models perform better than others in certain circumstances. Some models perform better than others at different lead times. Since we're talking about now and the next 24 to 48 hours, these large scale temperature, pressure, and wind patterns typically won't differ too much between models. So that's why I'm not really paying too much attention to what models I'm showing you because they're going to be pretty similar. Um, this is a different type of thing to look at. It's called a time height, and the University of Utah has um, some good versions of these. I like these a lot when trying to figure out what's going to happen with a storm because they contain several different pieces of information at the same time presented in a way that is clear to me. We had to look at one map for the upper level pressure pattern, another map for the atmospheric scale lift, another one for the frontogenesis. Um, you get winds in here too and temperature, so that one's more informative. Um, but to see the temperatures a little more clearly, another map for temperatures, and then another one for just wind too. So that can be time consuming. But if you look at one of these time heights, uh, first you have to just accept that they read from right to left, uh, which is counterintuitive, but that's the way they set them up in order to display all of this information in the most helpful way. So you have Thursday at noon at the far right, and then Friday and Saturday going from right to left. The blue line is uh, the temperature, and you can see, for example, that the temperature is kind of staying consistent, and then Friday night at 6, it just drops. So that's where the cold front is. This is for Telluride. I picked Telluride because um, there's only a limited number of um, locations. I can use that zoom for these time heights, and Telluride is in the vicinity of, you know, it's in the San Juans. Um, so these large scale features are going to be pretty similar at nearby locations. So Telluride will be fairly representative of what's going on for a large part of the San Juans. Um, you can see these wind barbs pointing northeast, southwest to northeast. Those are the southwest winds. And you can see um, at different elevations, they do change a little bit. Um, but 700 millibars, which is indicated by the pressure on the y-axis, is the elevation that you can look at, and 700 is 10,000 feet. So that's kind of a good spot to look at the temperatures. The winds. And like I said, we're in that southwesterly uh, period right now, but you can see around, tonight into tomorrow morning, those winds shift to more due south, like we talked about, and even, on Friday, more southeast. Um, and then, even more southeast as we go later into the weekend. So it's a good tool to see the winds as time goes on, and um, the changing of the winds with the passage of a front. Um, and the freezing level as well, which is the blue line. Um, it's still pretty high. It's still warm in the Southwest, freezing level, between 10,000, 15,000 feet until tomorrow evening, when the cold front comes and drops the freezing level down to around 10,000 feet or lower. So yeah, I like this. It shows southwest flow during this period. The colors, the green and the brown, represent the moisture, the humidity of the atmosphere. Um, Anything that's shaded green is over 60% humidity. It's not really going to get too much precipitation with that, but once you get 70 to 80, you can, and then more than 80, it's more likely that you'll be able to get precipitation. Um, so during this southwest flow period we're in right now, there's not a lot of moisture being pulled into the San Juans yet, and that's why there's not heavy snow falling yet. But um, Friday night, tomorrow night into the weekend, you see these green colors get much darker and also go further down in altitude, closer to the surface, and that's where you're going to get more precipitation. So yeah, you get the winds, the relative humidity, the moisture in the air. You get the freezing level and the cold front. So this is a good tool that I like to use. And I also show the one here for Utah, to illustrate why this isn't a great storm. You have this southwest flow that we're in right now ahead of the upper level storm crossing the region and ahead of, the cold front. You can see here, around 6 p.m. this evening is when the cold front started to come through. And, because it's kind of falling apart, like I mentioned, you have this kind of gradually sloped line where temperatures are cooling over the next, 24 hours. Um, yeah, I wonder if I can pull up an example of where the temperature is falling more sharply, so you can see what it's more likely to look like. I don't know if any of these go back far enough. Well, this is further in the future, but you can see that you know this line is almost vertical. That's a warm front, but the temperature is changing much more rapidly than what we're seeing with this falling apart cold front in Utah. And then just switching how long this figure goes out to. So this cold front, is moving through now, and then we get a brief period of northwest winds here where the orographics are best for northern Utah post frontal northwest winds, but you know they quickly turn north northwest and then north. And temperatures go up too, but it's really not a particularly favorable post frontal atmospheric setup. So that's why I don't think it's going to snow too much after mid morning tomorrow. This is kind of where you're going to get the best chances for snow, where it's cold and moist and northwest, but it's just not lasting that long. And these winds at around 10,000 feet are also pretty weak. We're starting to get into the northern fringe of that closed low, so the winds aren't particularly strong during that time where the position of the low is. So even though we're getting some northwest winds, they're not that strong, and not strong enough to produce a real intense orographic wind, orographic precipitation event. So that's what's happening in Utah and why it'll snow, but it's not going to be anything crazy. And, another thing to note with these closed low pressures, especially when it comes to forecasting, we have the general idea that the storm has been, for many days, the storm is going to come into the west like this, an open low pressure, and then it's going to close off over the southwest. But predicting the precise location of where the center of this low is not easy to do many days in advance. We knew it was going to happen, but whether it's 100 miles to the west or east or north can drastically impact the wind direction in all of these locations around it, and the wind strength too. Um, so that makes these storms a bit tricky to forecast too. Um, all right, now let's get into some totals. This is a website that takes data from the National Weather Service, the government. It's a product from NOAA that combines many, many, many models together. And you've probably heard people talk about it, the national blend of models. It's a really good product in general, more accurate typically than any individual model. Um, and, uh, you can view national blend of model data on various websites. For example, WeatherBell. This is like the national blend of models snow forecast, and it's showing it in map form. So you can see where this wonderful model blend thinks the snow is going to be. In this case, I'm looking at this data in a different format for individual locations, specific points. In this case, I pulled up Molas Pass in southwest Colorado in the San Juans, as well as Red Mountain Pass in southwest Colorado, southeast of Telluride, and Columbus Basin, again in the San Juans, but closer to Durango, more on the southern side of the San Juans, where I think we'll do better. And then also Alta too, because that's close to where I live. But let's look at Molas Pass first. And there's a lot of great information on this website, but I'm just going to look really at the snow total for this specific point location rather than on a map where it's harder to zoom in and look at specific locations. I mean, sure, I can figure out exactly where on this county map Molas Pass is and then try to figure it out, but that's kind of a pain in the ass. So this gives you a point forecast, and it has a period of heavy snow from 5-ish a.m. tomorrow morning through midnight tomorrow. That's kind of the jackpot for the heavy snow in southwest Colorado. And then there's some additional snow from Friday night through Sunday, with a total of 17 inches from the national blend of models for Molas Pass, which is solid. It's good. Another thing you can look at, which is nice, is the snow level. I mean, normally we're looking at temperature maps like this, amongst other things, to come up with what the snow level might be. This condenses it all using many, many models, as I said, to give you a snow level on the left side of the screen here. Sorry, this is where the snow was, this blue line, where I got that 17-inch number. And then the snow level is up on the left here, indicated by the lighter blue line. Maybe I can zoom in so you can see it better. And yeah, so, it's starting around over 11,000, like I said, it's between 10 or 15. 11,000 was the forecast for this afternoon, dropping to around 9.5, 10,000 tonight as that cold front moves through, and then down to 8,000 feet Saturday morning. But you can see it kind of quickly goes up again, kind of right in here. And that's what we were looking at back here. When we saw, down here in Southwest Colorado, we're getting colder, we're getting a little cooler, not super cold, but then it warms up again with these darker colors. Because that cold front never really gets there in a organized way, and it'll drop back down again. But these are some fluctuating snow levels that are not really ideal for a couple of reasons. Not great for snow quality. You might get some upside down snow in there, and that can be problematic for avalanche conditions as well. Um, Ideally, and more often than not, you'll have the temperatures drop and a cold front bring the snow levels down, and then it will stay down until an entirely new regime enters the region. A ridge or another storm might bring a warm front and then back down, but this kind of fluctuating while the same storm is hanging out is not really the common thing that happens. So that's also not great either. But yeah, so it was calling for 17 inches on the western side of the San Juans near, let me refresh it and zoom in. And yeah, so on the western side of the San Juans, but not that far south, kind of in this, in the center of the San Juans from a north-south perspective. And then similarly, Red Mountain Pass is 18 inches. You know, western side of the San Juans, but not even farther north. I expect that this total is a little bit higher, is because this point forecast is a little bit farther, a little bit higher up in elevation. But then we switch to Columbus Basin. So now we're looking at this spot, and I don't know if I can zoom in on that. It's tiny on my screen. But okay, this is Columbus Basin near Durango. The San Juan Mountains kind of, this is the southern edge of them. It's near the southern edge. Compared to those other locations we were looking at that were farther north, farther away from the southern side of the range. And not surprisingly, this National Blend of Models is calling for 24 inches there. I don't have the exact elevation, but that's not surprising. It's kind of following exactly what we would expect with winds that are, let me just pull up CalTopo. Maybe we can see the topography a little bit better. Got 3 bold people still watching this craziness. Okay. So this will maybe help you see the San Juans better. This is the San Juans, right? This whole thing. So when the winds are from the south, this area facing south on the southern side of the range. So the southern side of the range that's facing south, that's going to do best. When you get more of a southwesterly component, this part of the San Juans where Wolf Creek is actually faces southwest, and it's on the southern. So this area facing the wind direction, the mountain range itself is perpendicular to the wind direction when it's southwest. So that area would do better when the winds are from the southwest. And similarly, just given the topography of these mountains, southwest winds coming into this region in the western San Juans will do a little bit better than due south. There's a little bit less topography for the winds to traverse to get in there and cause good orographics. Um, southeast, it's a little bit, you know, it's not quite perpendicular to these mountains that are, kind of along the west to east running southern side of the San Juans, but yeah, similar probably impacts from south and southeast winds. But that forecast from the National Blend right around here, showing much more snow precipitation, just makes sense because it's closer to the southern side of the range. So as the winds come in from the south, the air is going to rise, condensation is going to happen, clouds, precipitation, and then the precipitation is going to fall in here on the south. Now you go further into the range, the mountains get higher, which can help get some more precipitation. But you also, are basically wringing out a sponge as you go north into the mountains, and less moisture is available when you get farther into the mountains. And that's generally kind of the thought process with um, orographic precipitation. There's a lot of little things that can maybe change that, but generally, the further into a mountain range you go, the less impacts from orographics you will experience because the moisture gets depleted where it first rises and rises enough to condense and cause precipitation. So that is why this forecast we're looking at is showing heavier totals on the southern side of the range. It's really just that wind setup. Quick look at Alta, calling for 10 inches between Thursday at 6 and Saturday at midnight, but most of that's falling by noon tomorrow. Sounds about right. That's during our window of decent orographics as well as some large scale lift still hanging out there. Yeah, that's going to have to be a pretty productive period for 10 inches. This is probably, let's zoom in. Yeah, the base. Yeah, this is at the base of Alta. So yeah, I'm a little bit skeptical of that, but maybe it'll happen. I think 10 inches is more likely for the mid mountain, but we'll see. So a good little punch from the storm in the cottonwoods tonight and tomorrow morning, while the dynamics are still good. All right, a couple more things, and then we'll call it off because this is a little bit over an hour. I'll just breeze through some quick things so I can briefly get into the forecast for the next storm. This is another interesting product from the University of Utah. They're called Ensemble Plumes. You probably heard about them. Ensemble models, unlike deterministic models, run a bunch of different potential outcomes with a bunch of different initial conditions, which can give you a range of outcomes as well as help you assess confidence in the storm. The normal models that we're looking at, that I've been looking at this entire time, are called deterministic. They take one set of initial conditions and just run that model out however long they do. Some models go out farther than others, but because you have just one set of initial conditions, the further out in time you go, the more different variables you have to estimate and predict. And so the farther out you go, the less accurate they become. Again, ensembles like we're looking at here run many model runs with slightly different initial conditions. And that's why you get a range like you see in these plumes. Each skinny little line is a different ensemble member run. So this one has a set of initial conditions that came out to show 58 inches for Red Mountain Pass. And then this skinny one down here that's purple with its own initial conditions came out with 9 inches. So you get a range of results. With deterministic models, you're taking the initial conditions from the actual data that you have from the atmosphere that we're getting from weather stations. These ensembles, um, change things up a little bit in the initial conditions to get a range. When these lines have a large spread, there's less confidence in the forecast. Um, in this case, again, this is for Red Mountain Pass in Southwest Colorado. We looked at that location over here from the National Model Blend. But, you know, this is a depiction of the American model and the European model and both of their ensemble member forecasts. And you can see that despite the large range with a handful of members showing extreme situations, it's generally showing, like 16 to 40 inches. That's a pretty big range. The thicker lines are the mean. Um, but, given that, I would feel safe to say that like it's probably going to be between, you know, 15 and 30 inches at 11,000 feet from this storm. Um, it's definitely going to be higher up. 11,000 feet's not that high for the San Juans, but that gives you an idea, a range, how much confidence, these outliers in the less than 10 inches and over 40 inches, those seem like whatever initial conditions were used were not great. Um, Whoever is still left in the chat, tell me so I know who I'm talking to. So that way I can just talk to one person. Who's still watching? All right. If no one's watching and responding, then they fell asleep and I'm just going to shut it off. I'll go for a few more minutes. So, yeah, that's a good estimate. It's a good tool for getting a range and assessing confidence in a storm. Um, Also pulled the same forecast up for that's also Red Mountain Pass for Alta. Um, Let me see. Do another one in Colorado. No. Okay. Alta, we have, they're kind of mostly within 10 to 25 inches, but the average is around 18. This is mid mountain. I think that might be a little high. Looks like 12 to 22 is kind of where the majority of them are stacked, with the means right around 18. So that gives you a good idea of what to expect. Arizona Snow Bowl. It's an interesting one. Is anyone still watching? If you are, can you chat in? I wonder if there's a way. Oh, oh no. There's two people. It says there's only one. Curtis. Curtis and Gen S. Are Curtis and Gen S still interested in more weather? Because it's been like 90 minutes and I'll just call it a night unless Curtis and Gen S are dying to get a little bit more info. Gen S, did my child fall asleep reasonably fast? Gen S would know the answer to this question. right, thanks, Curtis. I'm tired. I need to work, and it's cold in here. That was a marathon of weather stuff. Thanks for joining, Curtis. I hope to see you next time. I would love your feedback. This is the first one I've done. It's experimental. I want to provide information that people find valuable, not necessarily just what I find interesting or useful. You can message me on Instagram, I'm Luke Snow, or email me, stone.luke@gmail. I'm not sure if this live video stays in my feed because it's the first one I've done. If that is the case, you can provide your feedback there as well. But I'm just looking for feedback to make it better for next time. And Jen S can provide me feedback in a couple minutes when I go inside to warm up from my garage. And I will end the stream now. Thanks again for joining, Curtis. And I should have thanked the rest of the people while they were still here, but I will do that in a different format. Good night.